Welcome back to the deep dive. We're here to, cut through the noise and give you the insights you really need for your cloud native world. Today, we're jumping right into Portworx Enterprise. We're going to unpack its core functions, the things that make it such a key player in persistent storage for Kubernetes. And what's kind of cool about this deep dive is how we're doing it. We're looking at Portworx through, let's say, 10 critical challenges, stuff anyone managing data in Kubernetes runs into. Think of it like a blueprint, yeah. Understanding what really matters, pulled from the kind of knowledge needed for their pro certification. So whether you're getting ready for a big meeting, just trying to stay updated, or maybe you're just really curious about robust cloud native storage, this is your shortcut. A way to get genuinely informed fast. We'll hit on daily ops, setup, business continuity, performance tuning, security, the whole lot. So yeah, get ready for a solid understanding of how this tool can really change your data strategy. We're not just listing features, we're digging into the why. Why does this matter to you in the real world? All right, let's get started. First challenge area, keeping tabs on your clusters day to day. This is all about, the everyday stuff. Monitoring, verifying things are working. Super important to catch small issues before they blow up. So imagine you're the admin. You need a quick check size, availability, usage for all your storage pools across the cluster. What command do you reach for? And what unique info does it actually give you?
Right, that's a fundamental task.
Yeah.
Your main tool is going to be PLSecTL Service Pool Show. And PXCLO, for anyone maybe less familiar, is Portworx's command line tool. It's pretty powerful. What's really remarkable about this command is the snapshot it gives you. Real time, comprehensive. It's not just, raw numbers. It digs into the details. Size, status, those key usage metrics for every single pool. This isn't just a quick, is it up, check. It's more like an early warning system. Think about hitting a capacity limit during peak time, PXCTL Service Pool Show. Helps you see that trend way ahead of time. Lets you scale proactively.
Okay. So it's about avoiding that reactive scramble when things are already breaking.
Exactly. Proactive scaling, not reactive firefighting. It saves a lot of headaches.
Makes total sense, like a health dashboard for storage. But are there common mistakes, like ways people misuse it, or maybe edge cases it doesn't cover?
Yeah, a common one is just glancing at the USED percentage. People forget to check the status column. A pool might have low usage, sure, but if it's degraded or offline, that's a much bigger fire to put out.
Right. Status matters just as much.
Definitely. And the command also shows the type of storage, the underlying devices. That can be gold for troubleshooting performance issues. So yeah, read the whole story it tells you.
Good point. Okay, so daily checks covered. What about bigger things, like upgrades? You go through an upgrade process for the whole Portworx cluster. How do you know for sure, really know, it succeeded on all the nodes? That verification step seems easy to skip in a rush.
And if you step back, verifying that upgrade is, well, it's critical for stability. For data integrity, too. The command you absolutely need is pxctal get storage nodes. This isn't just some generic node status check. It specifically shows the Portworx version running on each node, individually.
Okay, so node by node confirmation.
Exactly. It's the recommended way, the definitive way, to confirm that cluster-wide upgrade actually landed everywhere. I've seen it happen. Admins think an upgrade's done, but there are a couple of nodes lagging behind on an older version. Leads to weird behavior, unexpected downtime.
Yeah, I can imagine. A nightmare scenario.
This command helps you avoid that.
Okay, so whether it's daily health or confirming a big change like an upgrade, these PXCTL commands are basically the admin's eyes and ears. Instant, vital operational awareness. All right, let's switch gears a bit from manual checks to, well, the intelligence built into Portworx. What if storage could sort of think for itself? This brings us to smart storage. We're talking orchestration, automation features that make complex storage tasks way simpler, really changes things for dev and ops teams dealing with Kubernetes. So next up is a key player here, Stork. What's its main job? What's its biggest impact in a Kubernetes cluster?
Stork. Right, stands for Storage Orchestrator for Kubernetes. It's a really fundamental piece of this smarter storage picture. Its real genius is how it extends Kubernetes. It pulls Portworx's advanced storage features right into the Kubernetes control plane.
So it bridges the gap?
Pretty much.
Yeah.
Before Stork, managing storage for K8's apps often felt like juggling two separate systems. Stork makes it seamless. The big contribution is letting your apps tell Kubernetes what storage they need directly.
So the application drives the storage needs.
Exactly. It's more than just automation. It's kind of a philosophical shift. Developers define storage needs right alongside their app code. No more manual handoffs, faster deployments.
That sounds huge for developer speed.
It is. And it handles, placing volume smartly near the pods, orchestrating snapshots for backups, managing data migrations, resizing volumes on the fly, all driven by Kubernetes.
So it's the brain making Portworx storage truly Kubernetes native.
You got it. Kubernetes storage orchestration, basically.
Okay, that's Stork handling the orchestration, making it all work smoothly with Kubernetes. But what about capacity? Making sure you don't just run out of space. That leads us to another really smart feature, autopilot. What's the key benefit there, especially for stopping those out-of-space problems?
Well, this gets to a core question, right? How
It's
do you stop storage issues proactively without someone watching it 24/7? Autopilot is Portworx's answer. Think of it like a silent, dedicated storage ops team. Always watching.
always watching. Sounds a bit creepy.
Huh. Well, watching consumption. It constantly monitors how much storage is being used in your cluster. When volumes or even whole storage pools get close to their limits, whatever limits you define, Autopilot automatically kicks off an expansion based on rules you set up beforehand.
Rule-based scaling.
Exactly.
Yeah.
It's not just convenient, it's about keeping your apps running without hitting storage walls.
Yeah.
Continuous availability, consistent performance.
So it prevents interruptions.
Right. Truly intelligent, automated management for volumes and pools. Saves you from those 3 a.m. disk-full alerts and the frantic manual scaling.
Yeah, nobody likes those. So Stork doing the complex orchestration, Autopilot handling the proactive scaling, these really do seem to automate away a lot of the traditional storage pain points in container environments. It's about letting the system manage itself smartly, freeing up humans for, more interesting problems.
Precisely. More strategic work.
Okay, let's shift focus again, something absolutely critical. Data resilience. Making sure your data is safe, accessible no matter what happens. Node failure, site outage, the works. Let's start with the basics inside a cluster. An admin wants 2 copies of data for high availability. Simple enough. What's the setting for that in Portworx, and what does it actually protect you from?
Yeah, that's core HA. The setting is simply REPL2. The replication factor, REPL, tells Portworx how many copies of the data to keep spread across different nodes.
Okay, so repeal 2 means 2 copies on 2 different nodes.
Exactly. So if one node holding a copy goes down, disk fails, power outage on that server, whatever, there's another identical copy instantly available on a different node.
So the application doesn't even notice.
Ideally, no. It ensures uninterrupted data access, keeps the app running. It's your protection against those localized hardware failures within the cluster.
Great for keeping things running smoothly day to day within one location. But what about the big disasters? A whole data center goes offline. We need something more robust for disaster recovery, something sending data to a remote cluster. What Portworx feature handles that asynchronous replication for true business continuity?
Right. If we look at the bigger picture for that enterprise-level protection against catastrophic site failure, you need PXDR, Portworx Disaster Recovery.
PXDR. Okay.
It's specifically built for cross-site data protection. It handles asynchronous replication of your volumes to a completely separate cluster somewhere else.
Asynchronous being the key word there.
Yes. Because over long distances, synchronous replication often isn't feasible due to latency. Asynchronous means there's a slight delay, but your primary site performance isn't impacted. It's crucial for when your main DC is just gone. Your data is safe elsewhere.
So you can bring up your apps in the remote site.
Exactly. Minimal data loss, get back online relatively quickly. It's really the foundation of asynchronous data replication for serious business continuity planning.
Okay, it's clear Portworx is built thinking about resilience. From local HA with repeal 2 up to full DR across sites with PXDR. Seems like data is pretty well protected.
That's the goal, covering a wide range of potential problems.
All right, moving on. Let's talk performance and protection. Speed and security. How does Portworx make sure apps run fast while also keeping data locked down? It's often a trade-off, right? But essential for modern apps. First, speed. How do you squeeze maximum performance out? Specifically, there's this thing about journal devices. What's the purpose of spec.journal device in the Portworx storage cluster definition? How does that actually boost performance?
Yeah, this is a neat technical detail for performance tuning. Think of your main storage drives like a busy highway. Lots of data traffic. Without a dedicated journal device, all the little metadata operations, tracking writes, managing snapshots, stuff like that, have to fight for space on that same highway with your big application data transfers.
Okay, so metadata competes with actual data I/O.
Right. By using spec.journal device, you tell Portworx, hey, use this separate, often faster drive just for metadata and journaling.
Like an express lane just for the control signal.
Exactly like that. It offloads all those frequent, small I/O writes, reduces contention, lowers latency on the main data path. Your main application I/O flows much more freely. The result? Better overall storage performance, faster app responses, smoother user experience.
Clever. So separating the metadata traffic keeps the main data highway clear. Makes sense. Now, the other side. Security. Data at rest encryption, pretty much table stakes today. Which Portworx feature handles encrypting data on the volumes, and does it do anything else for security?
That would be PX security. It's Portworx suite for data protection and compliance needs. Its main job here is encrypting data at rest. So data sitting on the disk is scrambled, unreadable without the key. Vital for compliance, like IPA or PCI DSS.
Standard stuff, but essential.
Absolutely. But PX security goes further. It also enforces role-based access control RBAC,
Meaning?
meaning you control who can do what with which volumes. Only authorized users or applications get access. Least privilege principle.
Okay, access control too.
And it integrates with external key management systems like HashiCorp Vault or AWS KMS, so you manage your encryption keys securely, separately. It adds up to a really robust security posture for your data.
Got it. So speed through things like journal devices, security through PX security with encryption, and RBAC. Portworx seems to tackle both. Powerful combo for enterprise needs.
Yeah, they address those core requirements head on.
Okay, last section. Let's talk about reacting to problems and getting the setup right in the first place. Staying ahead of issues, correct configuration key to a healthy cluster. Let's start with alerts, your first warning sign. What does a dry state change alert actually mean in Portworx, and why is it so critical for an admin to jump on it immediately?
What's really critical about dry state change is that it's not just some minor notification, it's serious. It means a physical drive in your cluster isn't working right anymore. It's unavailable, maybe detached.
A hardware issue, basically.
Almost certainly. And it needs immediate attention because that failed drive directly impacts the storage pool it was part of. Performance might degrade, capacity drops. Worse, if that was the last replica of some data, you could have data unavailability. Depends on your replication factor.
Ouch. Okay, so it could range from performance dip to data loss risk.
Exactly. It's a fundamental alert for cluster health monitoring. Ignoring it.
Yeah.
Yeah, that's asking for trouble. Recipe for disaster, really.
Definitely one to watch. So, critical alerts demand a fast response. What about getting things right from the start? Initial setup. There's a specific, maybe slightly obscure detail about host system requirements for Portworx. What's the deal with swap space on a Linux host running Portworx?
Yes, swap. This raises that question, why disable it? Portworx is very clear on this. Swap must be disabled on the host nodes. No negotiation.
Must be disabled. Why?
It comes down to performance and predictability. Swap introduces unpredictability. The Linux kernel might decide to move critical Portworx processes or their data out of fast RAM onto much slower disk-based swap space.
Ah, the OS interfering with Portworx's memory management.
Precisely. That causes random latency spikes, inconsistent performance. It messes with Portworx's ability to deliver that consistent high-speed I/O.
So disabling swap guarantees Portworx runs in RAM where it expects to be.
Exactly. It keeps operations fast and predictable.
Yeah.
It's a fundamental setup requirement for a stable, optimal Portworx operation. Can't skip it.
Good to know. Seems small, but clearly has big performance implications. And there we have it. From watching critical alerts like drive state change to getting the host set up right, like disabling swap, it's clear that proper configuration and ongoing vigilance are absolutely key for a healthy, fast, reliable Portworx cluster.
They absolutely are.
Thanks for joining us on this deep dive into Portworx Enterprise.
Yeah. And then maybe this leaves you with a question to think about. How could leveraging these specific Portworx features, maybe autopilot scaling or those journal devices for performance, or even the confidence PXDR gives you for DR, how could that fundamentally change how your organization tackles storage challenges in your cloud-native world? Think about the potential gains: operational efficiency, better resilience, data security, peace of mind. How does that translate to faster innovation, maybe even lower costs for you? Definitely something worth exploring further, really unlocking what Portworx can do.